Hello everyone, in this video we have some vocabulary to go through dealing with polynomials and polynomial graphs. So the first slide here tells you about leading term. If you're given an expression or an equation and they ask for the leading term, they just want to know what is the term that has the highest exponent. So in this expression here, the highest exponent is 4, so the leading term is 2x to the 4th. In the second example here, the highest exponent is 4 again. So the leading term is negative 7x to the 4th. It's called leading term because if we were to put that in standard form, we would sort all the variables from high to low, and that one would be first. Leading implies that it's the first one. Leading coefficient is another vocab term that's very similar, except this time they're only asking for the number in front of the variables. So a leading coefficient is the coefficient of the term with the highest exponent. So the first example here, the highest exponent is 5, and the leading coefficient is 11. They don't care about the whole term. They just want to know the number in front of the variable. And the second example here, the highest exponent is 5, so the leading coefficient is the 9 out front. A degree of a polynomial is the highest exponent in the whole problem. If there's a term with more than one exponent, you just add the exponents to find the degree. So in this first example here, we have an exponent of 5 and then an exponent of 3 and then an exponent of 1. The degree is 5. It's the highest exponent we see. Now the second one has multiple exponents in the same term, so you have to add the exponents. So in the first term, 4 plus 3 is 7. The degree on that one would be 7. Just to double check, the other one, 3 plus 2 is 5. That's not the degree. It's the highest total. So the degree of the second one is 7. The y-intercept is the point where a graph crosses the x-axis. So graphically, you just find where it hits the y-axis, and that's your answer. To find it algebraically, you change all the x's in the problem to 0, and then you solve for y. So in this example here, we see that the y-intercept is negative 6. And to find that algebraically, I just change all the x's to 0, and I end up with y is negative 6. Extrema are high or low points on a graph. Extrema is the fancy way of saying extremes. When something is an extreme, that means that it's out there, right? It's different. In math specifically, it means that it's a high point or a low point. Extrema is just the plural of extreme. If they ask for relative extrema, that means that they want you to look only in the middle of the graph pieces and not on the ends. And if they're telling you absolute extrema, that means they want you to look at the whole graph. Remember, minimum means low point and maximum means high point. In this graph example here, we have 3 total extrema. We have 2 minimums, 2 relative minimums, because there's 2 places where the graph bottoms out. And we have 1 relative maximum, and that's where the graph tops out. And in all of these, we're ignoring the fact that the graph goes up forever, left and right. Last 2 vocab terms for today. If a graph ever goes above the x-axis, we're going to say that it's positive in that area. And if it ever goes below the x-axis, we're going to say that it's negative in that area. If a graph ever travels in this direction, that means it's increasing. And if a graph ever travels in that direction, that means it's decreasing. So they'll give you a picture of a graph and they'll ask you, where is this graph increasing or where is this graph decreasing? And you just look at the trajectory of it. Remember, we read graphs left to right. So as you go left to right, if it's going up, that means it's increasing. If it's going down, that means it's decreasing. So that's all for today's vocabulary lesson on polynomial graphs and polynomial expressions. Thanks for watching.